On the left, there is a terminal thing for the Docker. And what I want you to do for the next step is open or launch the Drupal notebook. So if you are using Docker, to be consistent, let's first get to the RMG directory and then run this script, which is Jupyter stays notebook. Sorry if you have to have in all the online. However, if you are running RMG on your local machine without Docker, you can simply do like go back to your home directory and run Jupyter notebook. Okay. Which will be easier. So I will basically do the same thing. Okay. So after a while, it will show some log things saying the Jupyter notebook is off, and will post how to access the notebook afterwards. So what you can do open a web server on your machine. Oh, I did that. Local host 888 and enter. Some of you may get into a internet that asks you to input a token. If that is the case, then copy paste this part, the thing after the token, into the place where it asks for the token.
Gosh, yeah, that is true. What should I do? How control. There is a long kind of I'm gonna question.
I clicked the wrong thing. It's $3 a month. Do people follow?
Yeah, I have a question for you. If I do something that I don't want,
And I think my okay. Just as a side note, if you want to stop to the notebook session, you can go back to the terminal and do Control plus C. Control plus C. You don't know without plus, like it goes to
Control C.
like this. Like froze.
If I do this, right? Copy this.
Maybe.
Because in Windows, control.
I think one thing is if you open the browser, then you have to close the browser and you.
Oh, like Jupyter novel.
There's another sign out. A lot of market tools are available as free notebook, so yeah, worth to get familiar with how to use.
Now, step one.
Okay, let me just continue. So if you copy the files into the my RMG files folder, you can go to RMG Pi. There is a folder called my RMG files. Then for now, I don't have anything. I need to also copy paste into this. What I'm doing is I will do that with we scroll and really drag into that. I personally find it pretty easy to, transfer files between your local environment and the VS Code environment. So let me go back to the notebook. As you can tell, the files there. And if we open the files, then it will show you some format that has a lot of um, comments on each of the file and how to run it. So for the sake of time, please. So let me briefly describe how to go through each of the styles in the Drupal notebook. So do you see the up and down arrows on the top? You can click on that, which will change the sequence of cell. You can also use your mouse, click on each of the cells to change your targets on the cell. To run each cell, you can click the run here, or alternatively, you can do shift enter or shift return. So this import package cell runs about 5 minutes. So we can go a little slow while it's loading. So once you load all of the package, then the next step is load the mechanism. So in RMG, after you run an RMG job, there is actually three kind of format of mechanisms that are available in the output order. One for internal, one for temping, one for RMS. So in using RMS, you can either use the RMS file or use the temping file. So in this example, I will just show how to use the RMS file. So you can enter the path here. However, since I assume everyone just removed their container, let's do this step first. So by removing the comment and enter them, it basically what it basically do is it treat this cell as a terminal command, and it will run the RMG job on the super minimal example we ran this morning. And afterward, you will have this in routine.rms file. I guess for now, the first cell is still loading, so it's haven't been really executed. Once you load the mechanism file, you can enter the necessary simulation inputs in the next session. So for our demo example, the things we are concerned about is the initial condition where for this case, we'll just dealing with the case for 1000 K, 10 to the fifth R, and 2/3 of hydrogen and 1/3 of oxygen, which is basically the same composition and initial condition as the RMG model, the super minimal model we built this morning. For the T-span, let RMS know how long you want to simulate the system. And the example here is 0 to 1 means simulate from 0 second to 1 second. In this notebook, if there's anything in users input or you can try out, I will mark as user input required or user input optional. For the cells that you don't have to change, or just put it no user input required. Once we input everything, so we can start to set up and run the simulation. So the first thing is to make the ideal gas phase. Basically, you tell the system what are the mass content in the system. As you can tell, so this block is running the Superman mode job. So let's neglect it for now. So for this, we will holding all the species and reactions within the mechanism file and make them an ideal gas. So those model nodes, we should treat all the whole mass content as ideal gas.
And RMS is a package within RMG that we.
Yeah, RMS, we'll get back to that at the very end. But RMS is a simulation package distributed with RMG. So once you install RMG or using the RMG Docker file, you directly have RMS available. Well, there are also many other simulated tools like Camkin. However, Camkin is commercial software, so you have to have a license to run.
Okay.
RMS is open source. Once you set up the ideal gas space, which is the mass content, then you can set up the domain, basically the kind of the boundary condition for the system. For this system, for this example, we'll just use the constant V domain, meaning the constant volume adiabatic system. And it's a 0D homogeneous system.
Can you go up a little? When we have to rerun for the super example.
Yeah.
Like after we run this one, we have to run the previous this one, right?
Okay, good question. So after run this section, we will finish generating the super minimal model, then run this section so that model can be loaded into the computer.
Oh, okay.
Could we move that cell up maybe then?
Yeah, maybe in the future.
Okay.
Yeah. This is a new paradigm. We do literally it's not.
Okay. Yeah, I guess if we didn't have to delete, then this would already exist.
That's a good point. So let me continue. So in this example, we set the domain as a constant volume adiabatic homogeneous system. Once we have set up the ideal gas phase and domain, we can set up the whole reactor, which includes the domain, the initial conditions, the mole fractions, and the time spans, and all the parameters. You don't have to worry about this three blocks for something for a similar simulation, like for the rapid compression machine or shock tube. You can just keep the three blocks as it is for your future like simulation. Afterwards, we'll solve the ODE as the reactor block will construct all the ODE formulation. So in this, you can change potentially you can change three things. One is the solver for the ODE. Currently, we use CVOD PDF, which is the solver that also used by Kintera. But you can definitely change it to others if, say, if your system is pretty stiff or you need some tailored the ODE solver. You can also change the absolute or the relevant tolerance. So as you can imagine, a higher tolerance can give you a more accurate simulation. And this can be sometimes really important to have a very tight absolute tolerance for simulating, say, oxidation reactions, etc. However, the tighter the tolerance, the more costly is the simulation. There's some trade-off, but usually I think for RMG models, we recommend to use absolute tolerance that is tighter than this, meaning use a smaller value for this. once you finish solving all the ODEs, then there's a set of simulation object, meaning transform the original RMS results into something that can be readable and output easily. You can keep it as it is. So at this point, we have done the simulation and probably want to do some, simulation analysis afterward. The first example is to plot the mole fractions as a function of time, basically the time history mole fraction. This example here, what it means is you want to plot the mole fractions for up to 1 second, and if the species mole fraction is greater or equal to 10 to the minus 7 mole fraction. And this is what I got here. As you can tell, the hydrogen and oxygen concentration stay almost constant for a while, which we usually call it as an emission period type. And all of a sudden, there's a sufficient, there's enough amount of radicals, then the system ignites, and you will get the result. Say, the O here is not really oxygen, but like water and some other side products.
If, for example, to see only, for example, one species, one
Yeah, this function actually can do this thing. Sorry.
What was the
now
question?
So let me repeat the question. So Koreana wants to see only one of the species, not all of the species, or a list of species instead of depending on the following. RMS does this functionality. I simply change some of the syntax, but I don't include all the details here.
Okay.
Possibly, probably may talk about it later, but we can include it in the once we finish the workshop and make this model better. Then there's a plot diagram. So you can choose a time to plot the plot diagram. This is automatically generated by some software, so sometimes it can be really messy and hard to read. But this is a useful tool to have, and for quickly check whether there's some of the flags are visible or not. If I remember correctly, so you can tell for each species there's a circle with some thickness for the age. So the thicker the age, meaning the more concentration the corresponding species have. So basically, at this particular time, there's a lot of hydrogen, oxygen, and some water, but pretty few hydroperoxide. And for the arrows, it means the flux. It basically indicates all the fluxes. So I think the lighter the color and the thicker the arrow, meaning there's more flux, while the thinner the arrow and darker the arrow means less flux. You can definitely change this number and try it out at different times. Another thing some modeler may want to see is the ROP, which means rate of production. Basically, it tells you regarding a single species what reactions kind of form it and what reaction does consume it. So for the example here, you can input a time and then input the species you care about. Usually in an oxidation system, it's hydroxyl radical. And you can tell the first reaction does consume a lot of hydroxyl radical, while this part does form some of the radical. And you can change species to something like O, stand for water in the system, or H stand for hydrogen radical in the system. It's the other cases. You can not only plot the ROP for a single radical, but you can plot ROP for all of the radicals. Some people find it really useful when analyzing systems where like chain branching where chain branching um, need to be investigated. So one advantage of RMS is it also raises the structure of molecules in RMG results. So it knows which species are radical. So you can accumulate all this concentration for each of the radical and get this all radical ROP. So this is a pretty short demo for the RMS. Um, I guess for modelers, another huge part is people want to do sensitivity analysis, which usually takes pretty long to do, even for a single condition. So RMS does support multiple sensitivity analysis algorithms, and some of them are really cost efficient. So you can run kind of sensitivity within seconds, which you can easily, which can accelerate your iteration through model like improvements or model analyzing. And besides, RMAN also support things like model-based system for more complicated domains and phase or reactors. So please stay here, and you'll find some interesting lecture and demos in the RMS session, probably tomorrow afternoon. And for now, I guess people can play around with this logo, try out the numbers. If you have time, you can also run another RMG job, generate a different model, and use this logo from that model as well. Cool.
Okay.